In this experiment, we're going to be looking at the different wavelengths of light that are emitted as electrons make transitions in atoms. And because not all atoms have the same energy for their energy levels, different atoms, different elements give off different amounts of energy for those transitions. And so it ends up being kind of a fingerprint for each particular atom. So let's look at kind of what you're going to be using. First, I'm going to give you two tools that will come in handy. This is on page 3 of your experiment PDF, and you're going to be using this a couple of different places. One thing you're going to use is this equation up here at the top. When you use this, make sure your wavelength is in meters, not nanometers. And as I've put down here at the bottom, a nanometer is 10 to the minus 9th meters. So be sure you convert that. This also gives you the constants that you'll use with this. This will be your way to get between E, energy, and wavelength. Okay. Also, they give you this rainbow down here, this spectrum, and with it comes the wavelengths. And from this, you should know that violet lights are higher energy and shorter wavelength. But I also have another tool for you. This one is a tool to go between color and wavelength, and it's a little bit more clear where to cut those off and so forth. But the thing to watch for on this scale, well, two things, is that these are in nanometers. And so you'll have to convert them if you need to go to energy. Also, the scale on this is really kind of weird. You'll have to look at these numbers carefully to decide how much each line is worth. Anyway, so I'll leave it to you to kind of figure that out, looking at where they cut off. Also, like if you have something that's red and you want to say its wavelength, it's okay to just kind of estimate in the middle of red and read off a wavelength for that. If you have something that is like described as orange red, then just go with the transition there. Anyway, so this will give you cutoffs for the different light, and they're a little subjective, so that's why I give you this. So the first part, you're going to be describing some spectrums, and they give you the wavelengths at the bottom. And so what I want you to do when you describe these is to give me the color and the wavelength. And you may use those two tools that I showed you before to come up with the color and the wavelengths of the different lines. On this one, this one I don't even think looks right, but on this one I would just describe it as blue, green, and red, and I wouldn't worry about wavelengths. This, like I said, this one looks kind of funny to me. Doesn't look right. So when you're describing these, you don't have to do drawings. You're just going to do words, and for those words you're going to give me describe with color, and wavelength in nanometers is fine. And again, those two charts that I gave you can help you distinguish the relationship between color and the wavelength. You can get, so here's these, let's look at these. So you can get the approximate wavelengths from these charts. And so, for example, on this one, I would probably describe this one's wavelength. You need to give its number and its color. Again, you can use that chart. On this one, so on these, when they get really busy, there's no point in naming each one. You can just say, you know, there's a cluster from these wavelengths. And, you know, describe some of the main ones that you see. When they get so busy like this, I would just like kind of divide them into groups and say there are so many, and you could just say that the total range goes from, you know, down here to up here. I'm not going to get real picky on your descriptions, but do give me some information about colors and wavelengths. Okay, again, a lot of lights. You might pick out some of the bright ones and specify those. Okay, on this part, this is where you're going to be using that equation. And so page 3, and where it says theoretical energy, this is E in that equation. Notice that these are in nanometers, so you must convert to meters and use that equation on page 3 of your PDF. Then we get to the flame tests, and I don't like their picture at all. The numbers or the colors are really hard to distinguish. So you're going to do the same metals, but use my chart, and I also give you an interpretation because a couple of those are kind of hard to distinguish. If I say like sodium chloride is kind of yellow-orange, it is a judgment call, but this will help you with the with your questions and stuff. So for its wavelength, I would go to my chart where I label it and go to the kind of the transition between yellow and orange. Let me show you. So just say you needed that wavelength for yellow-orange, I would just come in right here at this transition and read off something. These are kind of rough numbers, so don't worry about that too much, but they should be in the right range. Make sure that you look at what the scale is on here, like what each line represents. It's not what I thought at first. And so again, on these, because I'm giving you the colors, do come up with a wavelength for each one in your description. So here's your observations. Color and wavelength is what I want on each of these. In this top one, this is where you're going to have to use my chart to come up with an approximate wavelength and then convert that to energy. And I think the rest are pretty straightforward. The last one, on this one, I'll give you a hint. You might think about why we use chlorides, you know, why we're using potassium chloride and lithium chloride and so forth. And then the last one, again, this is where you're going to have to use some of my charts to correlate the colors with the energies. And that should be all you need.